Hello, welcome to Step Support Programs Assignment 16. I'm going to be going over the step question just from the assignment, it's question 3. And the first thing I should say is, 100% have had a go at this question before you look at the solution, before you look at the hints or the video solutions. That goes for almost every step question. I don't know why I said almost every step question. And also, it might be helpful with these modules to do the preparation and warm-up, okay, especially this one, they're quite sort of good preparatory ones. Okay, so let's just jump in. Oh, I should also say, if you got stuck at a certain juncture and then we do something that solves that bit, but then you didn't try the rest of it because you got stuck, then we pause the video and then do the rest of the question, or attempt the rest of the question. Okay, so the first part asks us to show that cos of 15 degrees is some slightly nasty surrogate expression, and to find a similar expression for sine of 15 degrees. Now, originally this might look a little bit intimidating, but because we know cos of 30 and cos of 45, we never really work with cos of 15. By the way, if you happen to know what cos of 15 degrees is, you can't just write down, it's this because I know it is. Okay, you're allowed to assume the knowledge of cos of 30, cos of 45, because this is from A level, or GCSE even, or something similar. And they are testing that you do know these things, but you can't just use other random knowledge like that, like cos 15. Okay, so the first thing we notice with 15 is that it's very like 45 and 30. Okay, in that it's 45 minus 30, or 60 minus 45, or however you want to do things. If you're really adventurous, you can say it's the same thing as 150 minus 135, or whatever. But anyway, we know it's 45 minus 30, and we also know our formula for addition and subtraction inside of cos. So for any two angles, we've got cos of alpha minus beta is the same thing as cos of alpha, cos of beta plus sine of alpha, sine of beta. Okay, so setting alpha to be 45 and beta to be 30, because I want to get 15, I get that cos of 15 degrees is the same thing as cos of 45 degrees times cos of 30 degrees plus sine of 45 degrees sine of 30 degrees. Okay, now we know these. Okay, that's equal to root 2 over 2. Oh, that's very bad, root 2 over 2. Root 2 over 2. This is the same thing as root 30 over 2. That's cos of 30. Sine of 45 is root 2 over 2. And sine of 30 is equal to a half. Okay, so now we can just evaluate this. Root 3 times root 2 over 4 is root 6 over 4. And then we get plus root 2 over 4. And we just divide through it by root 2 to get the required expression. Okay, so now let's try and do the same thing for sine. If something's not broken, don't fix it. So let's just do exactly the same trick. Okay, we've got sine, we've got an addition formula for sine as well. Sine of 45 minus 30 is the same thing as sine of 45 degrees cos of 30 degrees minus sine of 30 degrees cos of 45 degrees. Okay? And now we can just evaluate exactly the same way. Sine of 45 is root 2 over 2, cos of 30 is root 3 over 2, so we get our root 6 over 4. And then sine of 30 is half, and cos of 45 is root 2 over 2, so we get a minus root 2 over 2. And we get root 3 minus 1 over 2 root 2. And we can be relatively satisfied that that's similar to root 3 plus 1 over 2 root 2. Okay, so that's the first part done. And it wasn't too bad. So now, also I should use one other thing. I've used this symbol here. You've probably seen it now at this point because we're on assignment 16. This is the imply symbol. There's also this symbol, like 3 dots, which is therefore, that's how you read it. And there's also a similar one, which is like that, which is because. And these are helpful symbols that you can use to make your writing a lot more clear. I am not going to write everything out exactly how I would on paper, or like in exactly the most clear way, because I'm using the fact that I can talk as well, which you can't do in an exam. But to see like ideal way of laying out solutions, even the same solutions sometimes, look at the PDF solutions for these assignments, and you'll get a really good sense for exactly how you should be laying things out. Well, not necessarily should, but a very good template. Okay, so now we're on to part 2, which asks us to show that cos of alpha is a root of 4x cubed minus 3x minus cos 3 alpha is equal to 0. So bad at these signs, you'd think I'd know by now, wouldn't you? This is polynomial, has the root of cos of alpha, and find the other two roots. Okay. So maybe you've solved some cubics in your time, maybe you haven't. But the typical way of doing it in A-level, I'm not sure about other exams or boards, would be long polynomial division or spotting a root using a root. This is maybe going to be slightly awkward to do because we have this weird term over here. But we'll get to solving the actual cubic in a minute. Let's first, we've got this hint. Let's try and show that cos alpha is one of the roots. Okay, so as I said, this term's a little bit weird. My first instinct when looking at the polynomial is to try and figure out exactly what's going on with that term. Okay, so maybe I'll try and write that term in terms of cos of alpha, or in terms of things that I know relate to cos of alpha. So I'm going to try and derive a triple angle formula for cos. Again, if you know that there is a triple angle formula, if you know what it is, I would recommend don't just quote it. Okay, I would say actually you probably would lose marks for just quoting it. You can quote double angle formulas and stuff that are covered in A-level, but triple angle formula you'd be expected to derive on the spot. And it doesn't take long because we're going to do it now. Okay. So cos of 3 alpha is the same thing as cos of 2 alpha plus alpha, starting exactly how you would for double angle formula. And cos of 2 alpha plus alpha is the same thing as cos of 2 alpha minus sine of 2 alpha sine of alpha. Okay, so now we have our double angle formulas, we can get rid of the cos 2 alpha and sine 2 alpha. Now, cos 2 alpha I can write entirely in terms of cos. There are different ways of doing it. I could write it entirely in terms of sine. I could write cos squared minus sine squared. I'm going to do it in terms of cos because that's what I want to talk about over here. Okay, so that's the same thing as 2 cos squared alpha minus 1 times cos of alpha. Now, sine of 2 alpha is the same thing as 2 sine of alpha cos of alpha. That's cos sine alpha cos alpha multiplied by another sine alpha, we get a wee square there. Okay, good. And we're almost there. Okay, we've almost got it entirely in terms of cos, which is sort of the best thing we could have aimed for. Except for this sine squared. But we know that sine squared is 1 minus cos squared, so we can do it. Okay, so let's look. We've got a cos cubed term here, 2 of them, and then minus 2 times cos alpha times 1 minus cos squared. So we're going to get a minus minus 2 cos cubed alpha over there. So we get in total 4 cos cubed alpha. And then we've got a minus cos alpha from here, and then minus 2 times cos alpha. So we've got in total minus 3 cos alpha. Okay, good. So we say, oh yes, lo and behold, these are exactly the same two terms as these, and we're done. But we should still write it down. Okay, well, maybe it implies so 4 cos cubed of alpha minus 3 cos alpha minus cos 3 alpha is equal to 0 as required. The mathematician's way of saying, I told you so. Oh. Okay. I thought I did that. So that's it as required. I'm not sure if it really shows up very well. I'm still learning with the chalk. Okay, so we've got our first root, cos alpha. And let's now try and find the other two. Okay, so as I said, it might not be the best thing to do to try and do like polynomial division or, trying to solve this cubic. We've already spotted one root. It might be difficult to spot another. We don't know. Okay, so a good technique in this case is to equate coefficients. Okay, this is often a good thing to do with polynomials because they're sort of graded, and sort of you get a lot of equations for your money, a lot of bang for your buck sort of thing. Okay, so now in order to equate coefficients, we have to have two sides. One of the sides is going to be this polynomial. The other side, so let's write that down. The other side is going to somehow sort of try and capture how we're going to get the other roots. Okay. Now we know one of the roots already. Okay. We don't know the other two, but we know that they're going to form a quadratic, like when you multiply the other two terms together. So I'm just going to call this quadratic A squared plus B x plus C, where A, B, and C are just going to be numbers. Complex numbers or real numbers. Okay. Now we can equate the coefficients as hinted at. So, thing to do is write down equate. Oh, that doesn't say coefficients very well. Okay. You really should say this is what I'm doing. Okay. Otherwise, you just look like you're pulling equations out of thin air. And even if they're the correct ones, you might lose a mark that really was just silly. Okay. By the way, okay. I'm not saying that you will lose a mark if you don't explain what you're doing, but it just always helps. Okay. And say you did something wrong, but you explained that you were equating coefficients or that you were solving this polynomial, and you did something wrong, you can still get marks for method, even if you sort of messed up the manipulations a little bit. So, always helpful. So and for yourself, if you make a mistake, to come back. So equate coefficients. Now, first thing I'm going to equate is the x cubed term. Start at the start. And especially this is helpful because there's only one way of getting x cubed out of these two brackets. Okay, so I immediately get from the left hand side, I'm doing x cubed. From the left hand side I get 4, and from the right hand side I get an a. Okay, so straight away I know what a is. Lovely. I'm just going to call that 1. Okay, so now let's do the constant term, because again there's only one way of getting it from over here, minus cos alpha times c. So on the left hand side I've got minus cos 3 alpha, and on the right hand side I've got a minus c cos alpha. Now, we know what cos 3 alpha is. Even better, we know what it is in terms of cos alpha. In fact, even better, we know it's got a factor of cos alpha, because it's 4 cos cubed of alpha minus 3 cos alpha. Okay, so we know that c is going to be equal to, cancelling the minus terms, 4 cos squared of alpha minus 3. Okay, good. I'm just going to call that 2, just in case I want to refer back to it. Sometimes you don't refer back to it and it looks a bit silly, but sometimes you do. Okay, and I'm going to equate one other. I could pick x squared or x. I'm going to pick x squared just because there's a 0 on this side. So maybe it makes life easier. So 0 on the left hand side is equal to, now there are two ways of getting x cubed. I can either get it from, x squared. I can either get it from linear times linear. So that's going to be b. Or I can get it from quadratic times constant. So that's going to be a minus a cos alpha, which implies that b is equal to 4 cos alpha, because I know that a is equal to 4. Okay, So, maybe I'll call that 3. Okay, good. So now I know my 3 coefficients. So the other 2 roots are the roots of the quadratic 4x squared. Now b was 4 cos of alpha. Now I'm going to call cos of alpha, I'm just going to abbreviate it to something else. Normally you would pick c, but I've already used c, so I'll pick gamma. Okay, so 4x cubed plus, 4x squared. Sorry. So it's this quadratic here with the coefficient. So 4x squared plus 4 gamma x plus c, which was 4 gamma squared minus 3. Okay, now we know how to solve quadratics. Okay, by the way, this is quadratic in x, not in gamma. We know how to solve quadratics just using our quadratic formula, so let's do that. Quadratic formula, x is going to be equal to 4 gamma. Oh, sorry, I don't know where the minus came from. Plus 4 gamma. I'm sorry if that confused you. 4 gamma, so that's minus 4 gamma, plus minus the square root of this term squared, which is going to be 16 gamma squared, minus 4 times the quadratic term, so that's minus 16 times the constant term, which is 4 gamma squared minus 3. Okay, and that's all divided by twice the x squared coefficient, which is 8. Okay, so I'm going to take a factor of a half out. Okay, and I'm also going to take the 16 out of the square root because it's a square number and it's staring me in the face. I take it out, and then that becomes a 4, and then divided by the 8 gets me a half. Okay, so this is going to look good at center. So I've got a minus gamma here, plus minus the square root of gamma squared, we're ignoring the 16s now, gamma squared minus 4 gamma squared plus 3, i.e. 3 minus 3 gamma squared. Okay? But now, we're looking pretty good because gamma was cos of alpha. So 1 minus gamma squared is the same thing as 1 minus cos squared alpha, which is the same thing as sine squared alpha. Okay? So square root of sine squared alpha is just sine of alpha. So now it's a half of minus cos alpha plus minus root of 3 sine of alpha, i.e. square root of sine squared of alpha, which is sine of alpha. Okay, so now we've got our other 2 roots. Okay, so maybe we can then write a sentence. So the roots are these 2 plus cos of alpha. Not plus cos of alpha. These 2 along with cos of alpha. Okay. So it turned out it didn't end up using the 1, 2, and 3, but maybe you could have. Maybe it was helpful for yourself. It's always better to have your work too clear, and take 10 seconds to make it clearer, than have it too messy and then take 10 minutes trying to figure out why you've just proved that 1 equals 2 or something. Which can happen quite a lot, especially when you're translating from schoolwork to step work. Okay, so now we're on to the final part. Okay, so it asks us to use parts 1 and 2 to solve y cubed minus 3y minus 2 equals 0, and to give your answers in terms of surds. I'm just going to stop it. Okay. Now, first things first. This phrase here, use parts 1 and 2, is very important. Okay, and it's the same sort of rules as A level, but it happens quite a lot in STEP because the questions are quite long. If they say use this, or hence deduce, or something like this, you must use what they've told you to use. Okay? It's absolutely no use, like, say they were getting you to derive a double angle formula in a really weird way, or something, okay, and you just derived it in a different way, okay, that was a lot easier. You don't get the marks for just deriving it, you get the marks for deriving it in the way they've asked you to, okay? Other times they'll say hence, comma, or otherwise, comma, and then you can do whatever you want, basically. So it's not the case that if you just are some sort of cubic solving genius and you just look at this and you're like, oh, I know exactly what the roots for that are, or you just happen to spot a random root and then spot the other roots and like don't use these at all, that's not good enough and it won't get you the marks, okay? The whole point is that you use parts 1 and 2 here because they haven't said or otherwise. Okay, so that's the first thing. Now, the second thing is, thankfully, it seems like we have a good chance of using parts 1 and 2 because we're being asked to solve a cubic that doesn't have, a quadratic coefficient that's non-zero, and we've just done that in part 2. There's a surd in the constant term, there was a really weird constant term in the last thing, so we're looking good. Now, there may be different ways to come up with trying the first thing that we're going to try here, but the stupidest, most foolproof, and sort of most sensible way, really, is the fact that we've been told to use parts 1 and 2. Now, in part 1, we figured out what cos of 15 and sin of 15 were. In part 2, we found the roots to a cubic that looked a bit like this, where in terms of cos of alpha and sin of alpha. So I'm just going to try alpha equals 15 in part 2. Okay, that is sort of the way to sort of come to this in terms of the structure of the step question. Okay, so try alpha equals 15. And by the way, if this doesn't work, we can try something else, but we'll go back to the drawing board. That happens sometimes in STEP. But try alpha equals 15 degrees in part 2. Okay. So we're going to get 4x cubed minus 3x minus, now cos of alpha, or it was cos of 3 alpha, alpha's 15, so it's cos of 45, so this is the same thing as 2. Okay, and now we're looking pretty good because this looks very like that. It's a minus root 2 versus a minus root 2. So I'm just going to multiply this all through by 2. This will be constant terms out the same. And then I'm going to get 8x cubed, that's a very bad cube, minus 6x minus root 2 is equal to 0. I'm going to call this star. Maybe I won't use it, but it's always good to. Okay, so now this is looking very similar to that. And then we see, oh great, if I put y to be 2x in here, or equivalently 2x to be y here, or to be a half y, then I'm going to get from this to this, or that to that. Okay, so see that if y equals 2x, then you get star. Okay, so we'll solve for x star and then multiply by 2. Okay, and it might seem silly to put these two sentences down, but really this is the cleverest part of the entire questions. This is like, you want to be clear for the examiner. Okay, good. Okay, so we're going to solve for x in star. Now, star is the same thing as this, just about a big 2, and that was with alpha equals 15. Now, from part 2, know that the roots of star are cos of 15 and a half times minus cos of 15 plus minus root 3 plus sin, root 3 times sin. Okay, so we know what the roots are, but we have to give our answers in terms of surds. So let's do a little bit of jiggery pokery. So cos of 15 degrees. We find in part 1 was root 3 plus 1 over 2 root 2. And it would be good to say by part 1 here. Okay? Just, it's always helpful to show you really are using parts 1 and 2. Okay? By part 1, I'm just going to try and give myself as much space as possible. Okay? Now, let's do one of the other roots. A half times cos minus cos of 15 degrees. And I'll pick the plus 1. Plus root 3 sine of 15 degrees. Can I write this in terms of thirds? Of course I can by part 1. It's the same thing. A half times minus root 3 plus 1 over 2 root 2 plus root 3 minus 1 over 2 root 2, which is what we got, all multiplied by root 3, sorry, which is what we got from part 1. Okay, and I'm going to take the 2 root 2 out, so that's 1 over 4 root 2. And I'm going to get a minus root 3 minus another root 3, so minus 2 root 3. Then I'm going to get a minus 1 plus a root 3 squared, so I'm going to get plus 2. Okay, in other words, I'm going to get minus root 3 plus 1 over 2 root 2. Okay, fine. We've got one more to go. The other one was exactly this, but with a minus here. Okay, so I'm just going to skip to this line. So that's going to be a half times minus root 3 plus 1 over 2 root 2 minus root 3 times root 3 minus 1 over 2 root 2, which gets me 1 over 4 root 2. So minus root 3 minus root 3, so that's just 0, and then minus 1 minus root 3 squared, so that's going to get me minus 4, which gets me minus root 2 over 2. Okay, so now we know our values for x. We're almost there. Okay, we can set. So, roots of y cubed minus 3y minus 2 are, where was it? This one multiplied by root 2. That's root 3 plus 1. No, not multiplied by root 2, multiplied by 2, because it's y equals 2x, sorry. That's root 3 plus 1 over root 2. Then this one multiplied by root 2. So minus root 3 plus 1 over root 2. And finally, this one multiplied by 2. Did I say root 2 again? Sorry. We're multiplying all of our x solutions by 2. Forget my tongue. Minus root 2 over 2 multiplied by 2, because it's y equals 2x. Get minus root 2. And we've got all our solutions in their insert form.